This is the 5.B.4 homework, 11.78, 11.84, 6.26, and 6.28. The first problem is a 5-step heating ice below 0 Celsius all the way to steam above 100 Celsius. It's Q equal MC delta T in the first step for 10 degrees Celsius, and that gets us 17.6 kilojoules. The grams change to moles to get 48.1 moles, so that times the heat of fusion gets us 289 kilojoules. Another Q equal MC delta T to raise the temperature of the water gets us 362 kilojoules. Boiling the water gets us 1,962 kilojoules, and then heating the steam is another 22.5 kilojoules for a total of 2,650 kilojoules. 11.84, the reason why steam causes worse burns than hot water is that when the steam condenses on your skin, it releases the heat of vaporization to your skin, and that is 40.79 kilojoules per mole. As the water forms its hydrogen bonds, it releases heat. Over here on the right, we have 6.26. 2 moles of NO and 1 mole of O2, making 2 moles of NO2, releases 114.6 kilojoules. So 1.26 times 10 to the 4th grams, changed to moles, and then multiplied by 114.6 over 2, gets us negative 15,700 kilojoules, or in other words, 15,700 kilojoules of heat released. In 6.28, we're supposed to find Q and W. So first we look at W. We have 3 moles of hydrogen and 3 moles of chlorine, but that will make 6 moles of hydrogen chloride, HCl. So that means you start with 6 moles on the left and end up with 6 moles on the right. Well, if the pressure is constant and the temperature is constant and the moles are constant, the volume of the container is going to be constant. So as a result, there really won't be any work generated by this reaction. It'll be 0 joules. Heat, though, it releases 184.6 kilojoules for every mole of reaction, or for every 1 mole of hydrogen and 1 mole of chlorine that make 2 moles of HCl. So since we're tripling the reaction with 3 moles, I need to multiply that by 3 to get negative 553.8 kilojoules. And then putting the two together, we can find the internal energy change, delta E, to be Q plus W, or negative 553.8 kilojoules plus 0, or negative 553.8 kilojoules.